Hi guys, it's Matt, and we're going to be going over problem 3 today. Again, that's from problem set 1, problem 3. I know this was giving a lot of people some trouble, and so we're going to go over that pretty slowly. First off, I'm going to explain how I would approach this kind of a problem. So the first thing I would do is read the instructions really carefully. And I know everybody's like, yeah, duh, I know that. But again, reading is half the battle with programming. So let's go through. Assume S is a string of lowercase characters. So right off the bat, we know we don't have to deal with any uppercase characters. That's really nice. Great. So now let's write a program that prints the longest substring of S in which letters occur in alphabetical order. So in other words, it wants us to do parts of S. So a substring would just be like, a string of words or a string of letters or characters you would think of that are in alphabetical order. So this AZ would be in alphabetical order. This BO would be a substring in alphabetical order, that kind of stuff. Also, this E, G, G, H would also be in alphabetical order. Oh, also that B too. So that's kind of what it's looking for right now. And we see the longest substring in alphabetical order is this output. And so this is our ideal output. We want it to print out longest substring in alphabetical order is B, E, G, G, H for this string right here. Cool. So optional, or this is like the added on complexity, is in the case of ties, print the first substring. For example, you'd want to print like the first. So say for example, there was A, B, B, C, D. Again, it's going to always print the first one in order. So that's telling us if the lengths of, whatever we're tracking our substring with is equal to the substring, it's going to always take the first value or the first longest substring. And we'll go into that right now. So as you can see, here is my finished code already. I did put in some comments. So I'm going to go through the logic of this code, and hopefully this makes sense to you. There is another way of doing this too. I'm not going to go into that just because I don't really want to do that. Anyways, so let's go. So I'm going to make 3 variables to start off with. Okay, there's one hidden variable from me right now, and that's that S, that longest substring that the grader's going to use. So for right now, I'm going to make a variable called counter, and I'm going to put it equal to 0. And this is going to go through my loop, and each time my loop loops through, I'm going to add 1 to the counter. That way, I have access to all these different indexes right here, okay, in my string. So the reason I'm doing this counter is so that I have access to, from the 0, so S is, at the bracket of 0 would pull out the A all the way up to the end of the string. The longest string, this is going to be where I'm going to be changing this variable as we go through if my tracker is in alphabetical order and greater than the longest string. So for right now, the longest string is going to be equal to the first letter in my string. And the reason I do that is just so it helps just set up my program so I don't have to worry about this one incidental case of the first variable. It just saves a lot of time and a lot of coding. So this is currently, and this is my comment right here, this is currently the longest alphabetical string, and it should be what we're going to output back to our string or our display, and that's where I get this last print statement. Print longest substring, that longest string right there. Okay. Now I need something to go through and start tracking the letters as we loop through. So if I'm at A and then I have AZ in alphabetical order, I need something to keep track of that. So this is where I'm going to call it tracker. And again, I'm going to start it from that first letter too, so I don't have like an empty string. And this is my scanner variable. And it's either going to add another alphabetically correct character onto itself, which means, again, in the case of if it was A in the beginning and then it loops through, it should add Z if Z is in alphabetical order or is greater than the character before it. So in this case, if I break that down for you, which would be right here. So if s.counter, which will be whatever my counter is that it loops through, is greater than the tracker minus 1. So I'm going to break that down really quick. So let's do the second loop through. So counter, let's say, equals 1. So if s counter equals 1, so s bracket 1 notation is going to pull out for me this z. If z is greater than or equal to tracker minus 1, well, what's currently tracker? Tracker is this A. So is Z greater than A? Yes, it is. Great. So now I'm going to come to this if statement. And if counter equals 0, counter doesn't, because counter equals 1 on this first loop through that we're doing. I'm going to do this else statement, which is tracker equals tracker plus that Z. So again, this is the syntax to do that. So again, I am reassigning tracker to A plus Z. Because again, if we substituted this in, this would be S1, and that would give me the letter, the value Z out. So Z would add on to that A, and then my tracker would become AZ. So now let's move on to this next if statement. If length of tracker, which in this case would be a length of 2, because there's an A and a Z, is greater than the length of longest string, which in this case it is, because the length of longest string is just 1, then we're going to reassign longest string equals tracker. Okay, so now my longest string is AZ, because those are in alphabetical order. Again, where are we getting that alphabetical order from is right here in this statement. This if statement is saying if a value is greater than the previous value, then it has to be in alphabetical order. So again, that's a logic statement because, again, Z is greater than, a B or an A or a C. Okay. And then again, this is to handle, sorry, I know I'm jumping around in this code, but I'll go back through and explain all of it. If counter equals 0, which on the first time it loops through, it is going to equal 0. Tracker equals or equates to, should equal s.0. Sorry, I had that wrong. So it equals s.0. And what that's saying is, don't do anything with that first value since I already plugged these guys in. Okay, don't get hung up about that too much. It's just saving me some headache with that. And then, so if this is not the case, that, again, this is the alphabetizing sentence right here, this if, Z is greater than A, say that wasn't true, then it's going to come and it's going to replace tracker to now equal whatever that letter is. So let's go through this and let's see where this else statement would come into play. So for the A and the Z, this would be true. And then as it comes to the Z and the C, if C is greater than or equal to Z, oh wait, that's false, so I can't do any of this coding right here. So I have to go to this else statement, which says now tracker equals C. And that way, we can start a new string. Essentially, we are resetting that tracker to have a new substring. And that's really important. That's how we get, these break-in words, okay? Break between substrings. And that's really important because you want alphabetized, where it's asking us for alphabetized substrings, and it's looking for the longest version of that. So that's pretty much what this code does right now. At the end of all this if and else, I'm going to add +1 to the counter. That way it's going to move from spot 0 to spot 1 to spot 2 all the way to the end. All right, so I'm going to reiterate all of this one more time, and hopefully this will make sense. Counter set to 0 because we want it to start at the A. Longest string equals A. Tracker equals A. And again, this is just to prevent some headache. And again, don't worry about it too much. It's just if I didn't do this, I would have to add more code. So this is an easy way to bypass that. For character in S. So what I'm doing with this for statement is it's going to go through and it's going to perfectly loop through however many letters or characters are in this S. Okay. Notice that we don't use that in our code at all. There's nowhere else that I use char. One of the interesting things is I could have substituted this char for an underscore, which just means I don't use this variable in this for loop. I'm just using it as, a way for it to keep looping through the length of what I want. In this case, that's the string right here. Okay, this is a common notation that programmers use when they don't actually use this element right here. They use this underscore. So for underscore in S, if, again, this spot right here, which is going to be the next section of the string, but in this first statement, it's not going to because counter equals 0, and these are already equal to 0. So if A is greater than or equal to A, which is true, if counter equals 0, then just keep it the same, and then I want you to add 1, because if this is true, this doesn't run, so we come to this. So now counter equals 1, so we go back through that for statement. If S dot, or bracket notation 1 is greater than or equal to tracker, which again is A, and S counter 1, so when S1 is going to equal 0, 1, so it's going to equal this Z right here, it's going to be like, yeah, that's true, great. If counter equals 1, or if 1 equates to 0, gosh, sorry guys, this will never be true ever again, besides the first time we loop through this. So we can pretty much forget about this part right here and just go directly to this else statement. So now tracker is going to equal tracker plus Z onto it. So A and Z. So now our tracker equals Z, AZ. And if the length of tracker, which is going to be 2, is greater than the length of the longest string, which again, longest string is just this A character right here, and this is AZ. So this is going to equate to true, and now longest string equals AZ. All right, so this was true. So it doesn't do this guy right here, and it just adds 1 to the counter. And as you can see, it just keeps going through, and then if we reach to, and I'm going to do this one more time so you see it reset. So now counter equals 2. Again, I'm going to run through that for loop. If S2, which equals in this case C, is greater than or equal to tracker minus 1, which would be Z, that's going to be false. So immediately we disregard all this code, and now we're going to set tracker equals to S of 2, which is that C character, to start a new substring. All right, and then we're going to add 1, so now counter equals 3. And then at the very, very end of the for loop, when it doesn't loop through the string anymore, it reaches the end, it's going to print out our longest string. All right, guys, one last thing is the way MIT wants it set up. If length of tracker is greater than length of longest string equals tracker, this part right here is interesting because the first subset that is in alphabetical order, that of the same length, is always going to be the longest string. That's just the way, instead of doing it like this, they want it to be like this. So it's not going to replace, a length of 3 alphabetical, like in order. So if we had like ABC and then you had like D, E, whatever, some other alphabetical ordered word, it's not going to replace it for the same length. If this video was helpful to you at all, please leave a like down below and subscribe, because it does help me make more videos and more content that can actually go into these problem sets a little bit deeper. All right, if there's any questions whatsoever, leave a comment below and I would love to address those as well. Again, please subscribe and please like below. See you next time, guys.